PhiloMath, your turn now. We're going to look at sequences and series. And remember, I'm not going through the basics of the chapter because your teachers are more than capable of teaching you those basics. So what we're doing here is we're taking a look at some of those test and exam questions that are going to catch you out if you're not well prepared. The remembers, as usual, your formulae, you have a formula sheet, but you need to know your formulae so that you're not wasting time searching on the formula sheet. The quadratic sequence formula is not going to be given to you on the formula sheet, so you do need to be familiar with that formula. The sigma symbol automatically means that you're going to be doing a sum. So your SN formula will be the one that you're going to use if you see sigma. Also remember this little trick. If you're given a sum and you asked for a term, suppose SN and they ask for T20. Remember, you can't just go S20 because that's the sum of 20 terms. You're going to go S20 minus S19 to give you T20. If you see the word converge, automatically means that you have a geometric series. And remember that R, your constant ratio, has to be between -1 and 1. Otherwise, your geometric series cannot converge. Okay, then lastly, I thought I would just pop in the circle information because the circle questions seem to pop up from time to time. And so many people get mixed up between the area and circumference of a circle. So your radii sequence could be something like 2, 6, 18, 54. In other words, multiplying by 3. Circumference sequence will therefore be 2 pi radius, 4 pi, 12 pi, 36 pi. You're still multiplying by 3. Your area sequence is pi r squared. So 4 pi, 36 pi, 324 pi. Okay, so now you're multiplying by 9 each time. Right, the first question, I've done the introduction for you because it's a fairly straightforward quadratic sequence question. So we're given the quadratic sequence, and they've asked us to determine Tn, so the Tn formula. Right, so I think that you are all familiar with this level 1 question. First differences, second differences. So I'm solving for A, solving for B, solving for C. Obviously, I'm substituting A over here, and I'm substituting A and B. And when I'm done, I have my Tn formula. Right, now, part 2 of the question asks what value must be added to Tn for the sequence to have only one value of n for which Tn is equal to 0. Okay, so I've put a little reminder in here that one value of n means one root, one x-intercept, keeping in mind that Tn, this formula, is a quadratic formula, and therefore we're dealing with a parabola. Okay, so we want to ask the question, what value must we add to this parabola so that it will have only one x-intercept? At the moment, we can assume that this parabola most likely has 2 x-intercepts, and possibly the best way to look at it is to find out what is the maximum or minimum value of this parabola at the moment. And once we've got that value, then we should be able to find out what must be added in order for it to have only one x-intercept. So what I'm going to do is I'm going to complete the square so that I can find the maximum turning point, the maximum value for this parabola representing Tn. Okay, I know you don't love completing the square, but for now, it's the only way we've got. Once you've done calculus, then you will be able to use calculus instead of completing the square. So at the moment, I'm assuming that you haven't yet done calculus. I'm completing the square by taking half the coefficient of n, but because I've added in 144, I'm going to subtract 144. Last but not least, I'm going to multiply the negative. That's going to be -1 times a negative is +1. So therefore, this parabola has its turning point at 12 and 1. Okay, so if I were to do a very, very rough sketch, not even going to put the y-axis in, it's an unhappy parabola turning at 12 and 1. Okay, so how am I going to move this parabola in order for it to have only one x-intercept? Clearly, I'm going to have to move it down by one position. If I'm going to move it down by one position, then technically I must be subtracting 1. Okay, so I no longer want to have this +1. I want to shift the whole parabola down by one position so that it will have exactly one value of n for which it's equal to 0. At the moment, it has two values of n for which it's equal to 0. So if I shift it down by one position, then I've got to subtract 1, and so it's going to be like that. So that's not a multiplication, that's adding -1. So what value must be added? We must add -1. Right, quite a complicated question, but a good one to have going into a test or exam. Next up, quite a standard question. Show or prove that this sequence cannot be geometric. Right, if it cannot be geometric, then we obviously are going to have a problem with our constant ratio, something in that regard. Okay, so what we're going to do here is we're going to do something called a proof by contradiction. What does that mean? It means we're going to assume it is geometric, and then we're going to find out what is the problem. So assume that it's a geometric sequence. Once we assume it's a geometric sequence, we're allowed to say T2 divided by T1 equals T3 divided by T2. So x plus 1 over 1 is the same as x minus 3 over x plus 1. If I multiply, cross multiplication, and so we have, that becomes +4. So there is my quadratic equation. Now I want to solve this quadratic equation, but I can see that it can't be factorized. So I'm going to quickly do delta. In other words, I'm going to check the nature of the roots. What kind of solutions am I going to get here? B squared minus 4AC. And it turns out that delta is negative 15, which means no real roots. In other words, if this sequence is geometric, then there are no values of x which are real. So it cannot be geometric because x has to be a real number. We can't work out of the real number system when we're at school. So we have proved that if it's a geometric sequence, it has no solutions for x, therefore is not a geometric sequence. Okay, remember that little trick of doing delta to check whether your equation has solutions or not. That would be for a quadratic equation. Right, here's the little question that I gave you in my remember tips. So it's just here again so that we don't forget about it. Given Sn, determine the value of T9. So remember what we said? We said T9 will be S9 minus S8. All right, that is a learning concept. Now we're just going to substitute 9 into n, and then we are going to subtract, and we're going to substitute 8 into n. That should be calculator work. And let's see what we get. T9 is equal to 49. Okay, so that is a very straightforward level 2 question because it's a concept that you can actually learn. Okay, let's have a look at question 4. And I think we'll make this the last question of this video, and then I will do a second video with the remaining questions. If the sum of the first 3 terms of a geometric series is minus 14, and the sum of the next 3 terms is 378, determine the value of A and R. All right, so it feels like a simultaneous equation because we're solving for A and R, 2 unknowns. So it feels like we need 2 equations. But it's a little bit unusual. Sum of the first 3 terms is no problem. It's a geometric series, so it's going to be A R to the n minus 1 over r minus 1, and they've told us that the sum is negative 14. Right, so that's not too bad. We have an equation that we can work with there. The problem is the next one. Call that equation 1. The sum of the next 3 terms. Would you agree that the next 3 terms isn't an S formula? Because we can't just go S3 again. It is 3 terms, but it's not the first 3 terms. So what we've got over here for the next 3 terms is we've got T4 plus T5 plus T6 is 378. We also know T1 plus T2 plus T3 is negative 14. So would you agree that if I went those 3 and those 3 all added together, so T1 all the way up to T6, if I added those together, that would be called S6. And so that's exactly what I'm going to do. I'm going to say S6 would be these two sums added together, which is going to give me 364. So now I have a formula for S6, which is going to be A r to the 6 minus 1 over r minus 1. And that is going to be 364. All right. Now I can solve for a and n because I have two equations. Okay, so what I'm going to do is I'm going to take equation 2 divided by equation 1. So a r to the 6 minus 1 over r minus 1 divided by a r to the 3 minus 1 over r minus 1 would be equal to 364 divided by negative 14, which is going to give me 26, negative 26. All right, this dividing isn't very pretty, but what we do know is the a's will definitely divide out with each other. The r minus 1s will divide out with each other. And so we're left with r to the 6 minus 1 over r cubed minus 1. Right, so I'm going to factorize r to the 6 minus 1. And I'm going to say it's equal to negative 26. Those will divide out with each other. And so I'm left with a beautiful that, which means r cubed is, sorry, that's minus 26. My brain is going ahead of me here. That's minus 27. And so r is negative 3. Once I've got r is negative 3, I can substitute back into either one of my two equations to work out what a is. So if I go back to equation 1, I'm going to have a negative 3 cubed minus 1 over negative 3 minus 1 is negative 14. That's going to be minus 27 minus 1 is minus 28. That's going to be minus 4. So that works out to be 7. So I'm going to take minus 14 divided by 7 is negative 2. So r is negative 3, a is negative 2, and we have solved quite a complicated question.